In these last two slide decks, we're going to talk about the need for IT security. Specifically, we're going to talk about threats and attacks. And the way I did this, I divide in these two presentations, I divide threats and attacks into threats being things that are vulnerabilities or exposure that we have to things that could affect the confidentiality, availability, and integrity of our data that are I don't want to say non-technical, but things that are that can happen to us that maybe there's no nefarious intent. There might not be somebody in control of that. Whereas attacks are when somebody is going out of their way to try to circumvent these controls that we have in place. So attacks are when somebody's actually trying to get through the controls that we put in place and trying to get access to that data and to thwart our confidentiality, integrity, and availability controls that we put in place. So again, in this presentation, this slide deck, I'm going to talk mostly about the things that can happen, the things that we have to protect against, that there's really no bad actor responsible for these things in most cases, although with software I'll talk about some things that are, but there are things that we have to protect against and some of the things that we talk about. And throughout the course, when I talk about different subjects in IT security, we're going to go back to some of these threats and attacks and talk about them. So for example, in risk management, we'll talk about the different threats and attacks and what the risks are of those threats and attacks. So first, we're going to define in this unit what these threats and attacks are, and then we're going to reference back to those frequently throughout the course to see what these different tools and techniques and controls and different concerns we have concerning all these different threats. One of the first things that your book talks about, and this is in chapter 2 in the textbook, well, at least in the edition that I'm using, which is the 5th edition of the textbook of Principles of IT Security. One of the first things they talk about is this ancient text, Chinese text, The Art of War. A lot of you guys have probably heard of The Art of War, but the Art of War, one of the central themes in The Art of War is to know yourself and to know the threats that you face. And that's a great way to look at IT security. Is first, we have to make sure we know about ourselves. We know what our environment is. We know what we have. We know what our weaknesses are. We understand all of that stuff about ourselves. And then we know what our external threats are, and we can put that in context as to what we know about ourselves. So mostly what we're going to talk about in this unit is knowing the threats that you face. And throughout the rest of the quarter, we're going to talk about knowing yourself, knowing what tools you can have, knowing what your risks are, knowing what you can do about this stuff, so we'll talk more about that later on. So one of the first things that we talk about as far as threats go is deviations in quality of service, or QoS. So a deviation in quality of service usually is affecting availability or access to our data or access to systems, access to the internet, and so forth and so on. One of the things that we talk about when it comes to quality of service is an SLA, or a service level agreement. So a service level agreement is sort of a codified agreement between two parties as to what level of service that you can expect from the other party. In other words, let's say you're paying an internet service provider for access to the internet. An SLA might define how much downtime is acceptable for your internet service connection. It may also codify exactly what kind of speed you should expect to get, what kind of burst you should be able to expect to get out of that connection. So maybe I sign a contract with an internet service provider and they tell me that they're going to guarantee me that I'm going to get 10 megabits per second at any given time, and I can burst to maybe 100 megabits per second, if needed in certain circumstances. They may also guarantee that I'm going to have 5 nines of uptime. In other words, 99.999% of the time, I will be able to use that service, which means that every year I might be down for a couple of minutes, and that's it. And by the way, 99% sounds like it'd be pretty good, but that's still, a lot of downtime. If a year is 365 days, 99% of 100 is 99 days out of 100. That means if 300, that's almost 3.5 days of downtime in a year if you have 99% uptime, which is certainly not acceptable for many businesses. So a service level agreement basically means that this is what I can expect out of my provider or out of somebody with whom I'm doing business or somebody that I'm relying on for some type of service. And if they don't comply, then I have some redress. I have some way of getting compensation for that. And it's important to have a service level agreement for anything that is important or anything that you're requiring some quality of service. So if you recognize that say electricity is super important. You're going to make sure that you have some way to make sure that you can maintain that quality of service in electricity for your data center, for example. And you may not be able to negotiate a good SLA with the power company. I mean, could you imagine calling your local power company and saying, listen, you guys need to give me 99.999% of uptime, or else you're going to have to pay me some compensation, right? I don't know if you've ever had your power die for a couple of days and you lose all the food in your refrigerator. But if you try to go to the power company and say, you got to pay me $1,000 for all the meat I lost, they're going to tell you to go pound sand, right? So we don't always have that option. So we have to find ways to mitigate those threats. So we have to mitigate those threats against our quality of service. So for example, with power, we could do that by having generators, for example. And we're going to talk about that when we talk about physical and environmental security. We'll talk about some of that sort of thing. So deviations in quality of service could be caused by network outages, hardware failure, power issues. The electricity goes out. You could have spikes in electricity, surges, sags, faults, noise, brownouts. Your book talks about a lot of these, and we're going to talk about those in much more detail when we talk about environmental and physical security later on. And of course, blackouts. And everything else that could cause some quality of service, anything that's going to cause some downtime in the service that you're offering your users. So again, that's quality of service. So deviations in quality of service is a threat to availability that we have to take into account and make sure that we have some plan to make sure that there are as little deviations in quality of service as possible. Another threat is forces of nature, and this is a pretty obvious threat. In an insurance policy, they call this an act of God. I'm sure many of you have heard the term act of God. So for example, if you have a car accident and you rear-ended somebody in front of you, that is your fault, right? Or if somebody rear-ends you while you're driving your car, that's the other guy's fault. That is not an act of God. But if you're driving your car down the road and lightning strikes your car and causes damage, that would be an act of God. Nobody caused that lightning to strike, except arguably God, depending on your belief system. But so forces of nature are things that they just happen, and we have to be aware of those. So some of the things that we talk about, and again, we'll talk about more of these forces of nature when we talk about risk, but fire is certainly one. Flooding could be another one. Earthquakes. Lightning can cause problems, landslides, mudslides, severe weather. Sorry, I spelled severe wrong there. Electrostatic discharge, dust. I know dust seems so benign, but dust is not good for computer hardware. I'm sure a lot of you guys know this. If you've taken CT100 or 120, they talk about this, and CT200. But dust can certainly ruin your day and bring services down. But dust is a natural thing. It's not something that somebody puts there, although I guess that could be an interesting attack, somebody injecting dust into a data center. But these are all different forces of nature that are threats to our information infrastructure that we have to make sure we protect against. Humans are certainly a threat. Now, I'll talk about humans being a threat in the next slide deck, as far as humans being attackers and things like that, but humans can be a benign threat as well. Humans could be a threat in the sense that they're not purposely trying to take things down. Humans make mistakes. So human error is a huge threat. Somebody could accidentally delete a bunch of data. Somebody maybe forgot to set up the backups. Somebody accidentally ran a SQL statement that updated all the wrong records or what have you. So we have to make sure we can protect against and mitigate the risks of human error. And then there's human failure. Humans that just forget to do stuff, didn't do something, whatever. But like I said, humans make mistakes. There's nothing we can do about that. We have to try to mitigate the risk of those mistakes and make sure we have some way to protect against that, and maybe some safeguards that we can put in place. And one thing I want to make clear here is that a lot of these human threats are not nefarious. A lot of this stuff is, it's not on purpose. It's just a benign human condition that that humans make mistakes, and we have to try to expect that and to mitigate that. All right, hardware failure. So technology is a threat. There are technology threats. There's three categories: hardware, software, and obsolescence. So hardware failure is something we have to expect that is going to happen. There's really no way around hardware failure. In fact, manufacturers of hardware, they don't tell you that a hard drive is, hopefully going to last a long time. They tell you that hard drives are going to fail. Every hard drive manufacturer tells you this. In fact, they stamp it right on the side of the hard drive. They tell you the MTBF of that hard drive, which stands for the mean time between failure. So the manufacturers, they test this stuff. They know about how long this equipment is going to last. Now, could it last longer? Absolutely. There's stories about incandescent light bulbs that have been burning for 100 years in a fire station somewhere up in North Jersey or California. I forget where, but yeah, there's those outlying cases where things can last a long time, but we can't count on that, right? You can't look at a hard drive and say, gee, this hard drive is 16 years old. Well, let's see how long it goes, right? We have to make sure we keep that data backed up. So like I said, the manufacturers, they know that things are going to fail, and they tell you roughly when they are going to fail by giving you that mean time between failure. So it's a good idea to look at that MTBF and understand when that stuff is going to fail. And incidentally, you could also look at the warranty expiration date. It seems like everything fails the day after the warranty expires, right? So there's also design flaws that can cause failure. This is common. This used to be pretty common with hard drives. You would buy a batch of hard drives and they would all fail in the first month because there was some flaw in all of that hardware. And good luck trying to get Seagate or whoever to try to replace them. It's just something that happens. There might be some kind of a manufacturing flaw or something along those lines. So sometimes things do fail before the MTBF. Just because there's an MTBF stamped on a device doesn't mean that it's not going to fail until that time. It can certainly fail prior to that, and that's usually some design or failure of the components or the manufacturing and so forth and so on. All right, finally we have software failure. Second to last here. Usually referred to as bugs, right? We've all heard of software bugs. Certainly happens. And there's a lot of different vulnerabilities in software, which I'm going to talk about in much more detail later on, but buffer overruns is one, command injection, cross-site scripting, uncaught exceptions, unencrypted data, poor change control, SQL injection attacks. There's all kinds of attacks that can happen. Poor usability, people can't figure out how to do things, so it causes the same errors over and over again. And again, all of this stuff it's important to be aware of. I am going to post a presentation in Blackboard that gives you a little bit more background on how these different attacks work. So I have some presentations that are for other courses. It's going to be optional. You don't have to review those, but it's great if you want to get some additional background on some of this stuff and see how a buffer overrun works or see how a command injection or cross-site scripting works and so forth. So I'll show you some of that stuff in a different optional presentation that you can look for in Blackboard. And finally, obsolescence. This is another threat that software is going to be obsolete, hardware is going to be obsolete. I put planned with a question mark because sometimes it seems like vendors plan for obsolescence. Microsoft comes out with a new version of Windows every 2 to 3 years, right? Or, well, sometimes 5 years. And at some point, they stop supporting the old version. So if they stop supporting it, are we still going to be able to get patches? Are we still going to get updates? A lot of that stuff goes away over time. So, if we can no longer patch and update software, it becomes an even bigger vulnerability, and it's important for us to plan for that. And that's an important part of IT security to say, okay, we know that Windows 2003 is no longer going to be supported by 2014 or whatever it is. So let's make sure we have a plan to reduce that vulnerability, to get rid of that exploit on our network, or do something to mitigate it if we can't replace those operating systems. Do something that can protect ourselves. And we'll talk about some of the techniques to do that later on in the course. But again, some software, at some point the vendor may turn off access to that software, especially if it's software as a service, for example. Or for example, it could be a perpetual licensing that stops working. So maybe every year you have to renew the license or renew the right to use software. And all of a sudden one day the vendor says, oh, I'm sorry, we're not renewing those licenses anymore. Go back and read your contract. As of 2015, we stopped supporting it and we stopped issuing licenses. And now you're stuck without that particular software. And you find yourself trying to backdate or something, right? So it's important to be aware of these things and know, that these things are going to happen and have some plan to mitigate this threat. So in the next and last slide deck, I'm going to talk about some of the attacks that we look at that we'll see in IT security. So I'll talk more about the attacks in the next presentation, and that'll be the last one.